The figures below show why the numbers in the sequence 1, 3, 6, 10 are called triangular numbers. You can see that as you add another row, you add 2 dots to make this 3 dots. You add another row of 3 to make a total of 6, and they form a triangle. They form the sides of a triangle. You can see you have 4 here around the sides to how many dots are here? 10. So what would the next entry in the table be? 15, 21, and 28. So we're adding 1 to the number we're adding every time. Is that a good way of saying it? All right. So if we look at the difference here, what's the difference? 2. Then 3. This is called the finite differences method, when you're figuring out how much the sequence is growing by. So the first question is, when you look at the first level of differences, are those numbers the same? No. So it's definitely not a polynomial of degree 1. It's higher than that. You look at the difference of those differences. What do they keep changing by? 1. Once you get to a consistent difference, you've found the degree of the polynomial. It's not the number it's changing by. It's how many levels it took to get there, to get to the common difference. And that took 2 levels. 1, 2. So we know the degree would be 2. Once you know that the degree is 2, you can get the equation like this. Here's the general form of degree 1, degree 2, and degree 3. This may come in handy for future problems that we do. If you have an equation of degree 1, the general form would be y equals ax plus b. When we studied lines, we actually wrote it a plus bx. But it is more traditional to write ax plus b, where a is the slope and b is the y-intercept. All you really care about is that the slope is the number attached to the x. Whether you use a and b, it's sort of irrelevant. If it's degree 2, it's going to be ax squared plus bx plus c. So when the degree goes up 1, you have to add an exponent and then tack a c on the end. Well, if it was degree 3, it would start with ax, what comes after 2? 3. It would be ax cubed plus bx squared plus cx plus, we need another letter, d. So imagine if it was degree 10. It would be ax to the 10th plus bx to the 9th plus yada 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 plus j would be the last letter, because j is the 10th letter in the alphabet. Alright? We usually skip x and y. Okay, so here we go. So what degree is this problem about triangular numbers? Second. So let's circle this one, and we're going to use it over here. So we have y equals ax squared plus bx plus c. What we're trying to do right now is figure out what a, b, and c are. How many variables are we looking for? We're looking for 3 variables. When you're trying to find 3 variables, you need 3 equations. If you were trying to solve for 4 variables, you would need 4 equations. 2 variables, 2 equations. 1 variable, 1 equation. You always need it to match. How many are you looking for? That's how many equations you need. So what we're going to do is we're going to take 3 points from the table above. Let's use 1, 1, 3, 6, and 5, 15. Why? Why not? If you wanted to pick 1, 1, 2, 3, and 3, 6, you could. I decided to skip a couple. So what we're going to do is we're going to take x and y, 1, 3, and 5 will be our x's, 1, 6, and 15 will be our y's, and we're going to set up a system of equations like it says in the hint right here. And we're going to use matrices to solve. So here we go. First, you're going to use 1, 1, and remember, we're putting in 1, 1. So 1 goes in place of y. A we don't know. X is 1. X is 1. We don't know A, B, or C. I'll get to a side note in a moment. The next point we're going to use is 3, 6. With 3, 6, which of those is y? 6. 6 equals A times X squared plus B X plus C. Many students from periods 1 and 2 stopped there because they realized that C has to be 0. So they knew that C was 0, and they just used 2 equations with 2 unknowns. I'm going to go a step further and make a third equation and see if it works by using 5, 15. Side note, the reason they knew that C was 0 is, look at the picture. If we went back a step, we lost 4 dots. We lost 3 dots. We lost 2 dots. What would be back here? Nothing. So in stage 0, you would have 0 dots. So C would be the y-intercept 0. Okay? That's a good discovery. It's not actually necessary, I don't think, because we can just put in 15 for y, 5 for x, 5 for x, and keep C in there. Okay, go ahead.
Is there going to be a point where you require us to use one method or another to solve it like matrices?
No. You wouldn't have to do it this way. You could just figure this out with logic if you were able to figure out the equation. Use elimination, that's fine. Okay, so any method will do as long as you get to the right solution. I am going to use matrices, and I'm going to make a big A matrix based on the coefficients that I'm about to circle. 1 squared is 1. This 1 goes in the middle. What coefficient is in front of all these C's? 1. All right? Let's get row 2 out of the way. 3 squared, 9. This 3 goes in the middle. 1, I already talked about. The final row, 5 squared. 25. Put this 5 in the middle, 1 on the end. That will be our A matrix. The B matrix will come from the 3 y's. Right here. 1, 6, and 15. Now, by the power of A inverse B, you should be able to enter these 2 matrices into your calculator and do A inverse B, and it should tell you your A, B, and C. We do A inverse B.